Okay. So negative 3x squared plus 3x squared will cancel. Okay, so that's gone. Then we have negative 4x, and 3 times negative 3 is negative 9x, which in turn will give you negative 13x minus 12. Then we multiply the half in, it's going to be half x cubed minus 13 over 2x minus 6. Alright, you guys understand? That's the equation we got now? Yes? No? Yeah, you guys are those girls again. No? Okay, any confusion here? No? That sum is normally worth 4 marks, okay? Let's look at example 2. There's quite a bit of examples, so I need to go a bit faster through this. And as you know, we are pressed for time already. As I was told already, you guys are not coming to school anymore because you're getting done for matric ball and all this stuff that you're wasting your time on. And we don't know what you guys are going through, no? So on page 171. Okay, so example 2 on page 171, consider the function f of x equals ax cubed plus bx squared plus cx plus d. From there we already know we are busy with a cubic function. Okay. So f of 1 is equal to f of 4 is equal to 0. Then we are told that f of 3 is equal to 8. And then f prime 1 is equal to f prime 3 is equal to 0. People, what does this tell us? F of 1 is equal to f of 4 is equal to 0. What does this tell us, this part here? Yes? If you put 1 and 4 into the equation, then you'll get 0, yes? What else? It's your x-intercept. Not so. So the here, number 1, they asked you to draw the graph. So if I draw here, I know the graph is going to go through 1 and through 4. Not so? And your y-intercept will be on this side. Right. F of 3 is equal to 8. What does that mean? X-intercept is 3? No. The graph is going through the point 3 and 8. Here the graph was going through 1 and 0. Here the graph was going through 4 and 0. That's why that was your x-intercept. Can you see that? Here the graph is going through 3 and 8. So if I plot 3 and 8, so there's the 3 is approximately there. So 3 and 8. F dash 1 is equal to 0. When do we set f dash x equal to 0? When we're working out our turning points. So this turning point is occurring at an x value of 1. So I draw that in. X is equal to 1. And x equal to 3. So what does that tell us with regards to 3 and 8? That is one of the turning points. You see that, people? So can the graph turn like that and like this? Of course not. Otherwise, how are you going to connect this graph here? You can't. Not so? So the graph is going to turn here and there. Can you see that, people? So we're going to do connect the dots. And there we go. That's your graph. That makes sense, people? I'll do it again. Yes, thank you. The question says draw the sketch of the graph of f and indicate the x-intercepts and the turning points or point. So we see here f of 1 is equal to f of 2, it's equal to 0. So when we set f of x equal to 0, we work out our x-intercepts. So your x-intercept here is at 1 and at 4. Okay? So f of 3, we know that the graph is going through 3 and 8. So there's 3 and 8 is approximately there. When you set f prime x equal to 0, we work out turning points. So the x values of these turning points is x equal to 1 and x is equal to 3, which coincides or goes through that point of 3 and 8. Okay, so the graph is going through 1 and 4. Can you see that, people? So remember, the graph is going to turn like that. Or you see, if I draw the graph this way, then the other turning point must be at the bottom here. Can you see that, people? But it's on top. So it can't be that way. Can you see that? So, considering the information given there, the graph is going to turn here and that there. So there's a function. There's your graph over here. Okay. Then it says determine the value of A, B, C, and D. Where do you get that from? Where are you getting A, B, C, D? You're getting it from the equation. Not so? But what do you notice? Remember, for that formula we have y is equal to a into x minus x1, x minus x2, and x minus x3. Not so? But what do you notice about this graph? There's two of the same here. Not so? So one occurs twice. Not so? So I must then in the formula represent it twice. And how do we do that? We say x minus x1 squared into x minus x2. Okay? So this is the substitution. What we have? Y is equal to a into x minus 1 squared into x minus 4. You will agree with that? See, anybody that's confused? Remember, the graph is bouncing off here. When it bounces off, it's a 2-in-1 solution. So what do we still need to solve here? For A. Okay? I just need to see something here quickly. I think I'm missing something. Here it says determine the values of A, B, and C. So what did I miss here? I only have A at this point. So I had to say, therefore B is equal to 0, C is equal to negative 13 over 2, and D is negative 6. I forgot to put that part in. Okay? Why? Because the question says calculate A, B, and C. And D. Okay? Just realize this now once I'm coming to this point. Right, so how do I solve for A here? You're going to substitute which point? 3 and 8. So you're going to substitute 3 and 8 into this equation here. Not so? So solve for A for me quickly. Remembering there's an x and a y. So we got 8 is equal to a into 3 minus 1 squared. 3 minus 4. 3 minus 1 is 2, squared is 4. And that is negative 1. So negative 4a is equal to 8. So a is equal to negative 2. Is that correct? Okay. So a is, which implies that a is negative 2. My equation now reads y is equal to negative 2 into x minus 1 squared into x minus 4. And as you can see here, the a value is negative. So what do you notice about this graph? First goes down, then up. Can you see that? So I'm just going to tidy this up a bit. So it's negative 2 into the binomial square gives you x squared. Let's write that x minus 4 first. And then left with x squared minus 2x plus 1. Then I multiply that in, so it's negative 2 into x cubed. X times negative 2x is negative 2x squared. Negative 4 times x is negative 4x squared, which is negative 6x squared. Then I get x plus 8x, which is 9x minus 4. Now if you can't do what I'm doing there, you write it out and you multiply the whole story out. Then you add your like terms in the next step. Okay? It's going to give you negative 2x cubed plus 12x squared minus 18x plus 8. Okay? Have I answered the question? No. There's your value for A. The value for B is going to be 12. The value for C is negative 18. And D is 8. Okay? Any confusion, people? Anybody that's confused? No? We look at example 3. Example 3 is on page 172. If it's a cubic function, okay, consider the sketch of the derivative of f by using f prime x equals. So you see the derivative is a parabola. It's a smiling parabola. So the function f of x will be a cubic function. Remembering that your turning point occurs at 2 and at 4. Since this graph is a smiling parabola, this is what the cubic function will look like. At the point of 2 and 4. Those are going to be your turning points. Can you see that, people? This here can happen there, or it can happen lower. But your turning points will be on these dotted lines. You guys understand? Okay. And that shape of the graph will be that. It says write down the x coordinates of the stationary points on f. So what are the x coordinates of the stationary points of f? X is equal to 2, or x is equal to, what are stationary points? Turning points. So where are your turning points occurring at? 2 and 4. Classify each stationary point. Okay? So at x is equal to 2, it will be a local. Is this local min or local max? Look at 2. What's happening at 2? It's a maximum. So a local maximum. At x is equal to 4, it's a local minimum. Why? Because the parabola or the quadratic function is a minimum value. Well, yeah, it has a minimum value. Therefore, for your cubic function, your maximum will precede your minimum. Okay, maximum will come first on your cubic function. Okay. Number 3. Number 3 says, determine the x-coordinate of the point of inflection of f. Where does the point of inflection occurs? The point of inflection occurs midway between your two turning points. Not so? And your two turning points is occurring at 2 and at 4. So what is your point of inflection going to be at? An x value of 3. Not so? Because a 3 is midway between 2 and 4. Okay, add it together, divide by 2. So x equal to 3. Then draw the sketch of the graph. I just draw the sketch. Okay, not so? What if they had asked you about the concavity? What did they ask you? Where's the graph concave? Down. For which values of x will the graph be concave? Down. For x is less than 3. Not so? Or for concave up, x must be more than 3. This part here is concave. Okay. So that question wasn't asked there. Let's see how they justify the answer in number 2. See what they say in number 2. We are told that if double prime of 2 is less than 0, so the graph is concave down at x equal to 2. So therefore the stationary point is a local minimum. Okay, so if double prime of x, so if you look at this graph,